So now let's take a look at this partial fraction decomposition example here. So the meaning of the partial fraction decomposition is trying to do something to rewrite this big rationale into a sum of partial fractions. Okay, and so negative 2x plus 4 over x squared plus 1 times x minus 1 squared. This can be rewritten into ax plus b over x squared plus 1. Okay, this is the format from the first factor, and then plus c over x minus 1 plus a d over x minus 1 squared. Okay, so this is the way how do we initialize this problem. And after that, we would like to figure out what is a, b, c, and d. Okay, those are the constants. So the idea is we're trying to let them to all have the same denominator, meaning, let me show you. So if you want to have the same denominator as the left-hand side, so for the first part, you need to multiply x minus 1 squared over x minus 1 squared. So the denominator is equal to this. Same logic, if you have c over x minus 1, you need to multiply x squared plus 1 times x minus 1 over x squared plus 1 times x minus 1, such that, you know, the denominator can match to the left-hand side. Okay. And then plus d times x squared plus 1, right, over x minus 1 squared times x squared plus 1. So right now, by doing this, you know, the denominator, it's the same thing, so I can add the numerator together, which give us is ax plus b times x minus 1 squared plus c times x squared plus 1 times x minus 1, and then plus d times x squared plus 1. Okay, so now, well, maybe let's only focus on the numerator because the denominator are the same. So the numerator is going to be negative 2x plus 4. Okay. And then after that, you need to do, so from numerator, this is what we can get. Okay. And then you can simplify the right-hand side into ax plus b times x squared minus 2x plus 1 plus c times, well, x cubed minus x squared plus x minus 1, okay? And then, of course, plus d times x squared plus 1. Okay. We can even distribute the right-hand side, which give us is ax cubed minus 2ax squared plus ax plus bx squared minus 2b x plus b, right? And then plus cx cubed, and then minus cx squared plus cx minus c plus dx squared plus a d. Okay, so that's everything on the right hand side. And then we can reorganize this into a plus c x cubed, okay? And then we're looking for the term involved with x squared. They're going to give us a negative 2a, negative 2b, right? And hold on, let's see. Negative 2a actually is a plus b, right? And then minus a c plus a d, then it's x squared, okay? And then plus, let's see the term involved with x, which is a, right? Minus 2b, and then plus a cx. Okay. And then, of course, the constant is b minus c plus d. Okay, plus d. So that's what do we have. Okay, so ignore this. Okay. So now keep in mind the two sides, they are identical. Minus 2x plus 4. That gives us, you know, a plus c is a coefficient of x cubed, but I don't have any x cubed on the left. So meaning a plus c is going to be 0. Okay. And the same logic, the coefficient in front of x squared is also 0 because there is no x squared on the left. So it's negative 2a plus b minus c plus d give us 0. Okay, so that's the second equation. Third equation we can get is the coefficient in front of x must be minus 2. So it's a minus 2b plus c equals minus 2. And then similarly, constant matches a constant, so it's a b minus c plus d gonna be 4. Okay, gonna be 4. So now I have 1, 2, 3, and 4. You know, this is called a system of linear equations. Okay. But, you know, we need to solve for ABCD. But since it's not that bad if you look at it more carefully. You know, if you look at A and C, 1 and 3, you will see that a plus c is 0. A minus 2b plus c equals minus 2. So if we put 1 into 3, in other words, substitute a plus c with 0, it turns out we have minus 2b equals minus 2, and then we get b equals 1. Okay. And similarly, same. You have b minus c plus d equals 4. That's from equation 4. But look at what we have from equation 2. I also have b minus c plus d here. So if I put equation 4 into 2, I'm going to have it's negative 2a plus 4 equals 0. It turns out our a equals 2. Okay. I got my a equals 2 here. So from 1, you can get that c equals minus a, which is minus 2. Okay. And then from 4, you can get that d equals 4 minus b plus a c. So that gives us is 4 minus 1 is 3 plus a c, which is minus 2, give us, so d is 1. So I get my a, b, c, d all here. Okay. And once I get that, my original problem, you know, this is those partial fractions, and then let's see, my a is 2, my b is 1, my c is minus 2, and my d is also 1. So I can rewrite this. So my integral gonna have integral. So it's ax plus b 2x plus 1 over x squared plus 1. Okay. So it's x squared plus 1. And then plus c, it's minus 2, so it's minus 2 over x minus 1. And then plus d, which is 1 over x minus 1 squared dx. Okay, so that's what I have. Now, for this integral, if we label this as 1, 2, and 3, so we can deal with them separately. So integral for the first one is 2x plus 1 over x squared plus 1. Now this problem is a little bit tricky because if you directly apply the u substitution, it will not work for this. However, if you split this integral into another two parts, it turns out that you can apply the u substitution for the first piece. It will give you ln of x squared plus 1. And for the second one, which is the tan inverse of x, which is 1 over x squared plus 1. Okay, so that's the first part. I did not put the c, add the arbitrary constant c, because to the very end I need to put the answers 1, 2, 3 together and add the arbitrary constant c. Okay, so that's equation integral 1. 2 integral negative 2 over x minus 1 dx. This integral is very straightforward, which is minus 2 ln of absolute value of x minus 1. Okay, based on the simple integral rule. 3, 1 over x minus 1 squared dx. You can still apply a simple u substitution, which you said u equals x minus 1, then du equals dx. Turns out this is going to give us is negative 1 over x minus 1. Okay. So our final answer is going to be ln of x squared plus 1 plus tan inverse minus 2 ln of absolute value of x minus 1 minus 1 over x minus 1, and then add an arbitrary constant c. Okay, so that is our final answer for this partial fraction decomposition problem. So the key point is to write into the correct partial fraction decomposition form and then solve those A, B, C, D algebraically. As we said, we let the numerator to be matched. You form this system of linear equations here, 1, 2, 4, and then most of the time, guys, just look at it carefully about the system of equations and to see that if there is something you can simplify. So in this example, 1 and 3 can be viewed as a pair, 2 and 4 can be viewed as a pair. So we can solve A, B, C, D correspondingly. And then we substitute our A, B, C, D back. So the problem transforms into this integral plus this one. And then we can solve them correspondingly. So I'll stop here, and I hope you enjoyed this video. Okay?